All right, this is University of St. Thomas, Math 005, Lesson 3, Part 2. We're actually really covering Section 2.1 in the book. I want to talk very briefly about the addition property of equality and the multiplication property of equality. And hopefully these are like really intuitive when you stop and think about them. But I want to make sure that we actually spell it out specifically. Our addition property says A plus C is going to equal B plus C if A and B are the same, if those two are equal. All right. This would be the same as saying 5 plus 1 is going to equal 2 plus 3 plus 1. Okay, those are going to be exactly the same results. Multiplication property, very similar concept. A times C equals B times C if A and B are the same value. All right. And this is useful when we're going ahead and breaking things down, solving our problems. I'm going to show in excruciating detail how to solve a problem using these properties. All right. So I've got a problem here that says 2x minus 1 equals 13. Well, I want to get rid of this minus 1. So the way I'm going to do that is I'm going to say 2x minus 1 plus 1 equals 13 plus 1. Now, I have to, if I add this here, I also have to add this here. I can't do one and not the other. So when I add these, this negative 1 and this positive 1 together, I'm going to wind up with a 2x equals 14, and then divide both sides by 2, right? If I divide both sides by 2, I wind up with my x is going to equal 7. Now, this is something that we don't do nearly as often as we probably should, which is to check our value to see if it actually does work out. I'm going to go ahead. I'm going to say this x is equal to 7. I'm going to plug that back into my original problem. All right. And I'm going to go ahead and process that. So I'm going to have my 2, and instead of an x, I'm going to put in my 7. Minus 1 is going to equal 13. So 2 times 7 is a 14. Minus 1 equals 13. So 13 equals 13. And while that doesn't sound very exciting, that's proof positive that we have the correct answer. All right. We'll do another one here. Maybe another 2. I want to go ahead and solve this next one. So it's 6y plus 17 equals 17. So I'm going to go ahead and, again, I'm going to write this out in extreme detail. You don't need to do this level of detail when you're working, unless you choose to, when showing your work. All right. Just, doing the subtraction down below instead of rewriting the whole thing, I would be just fine with that as far as how to solve this problem. So go ahead. These two are going to, this positive 17 and negative 17 are going to go to 0. So I've got a 6y. And then this 17 and this negative 17 are also going to go to 0. So that's going to equal that. So I've got 6y equals 0. Well, you can go ahead and divide by 6 on both sides. I mean, you're not going to gain anything by doing that. But your y is going to equal 0 in this case. And you can go ahead and, again, plug that back in. I'm going to say 6 times 0 plus 17 equals 17. Well, when I go ahead and do this, I'm going to have 0 plus 17 equals 17. And that means 17 equals 17. And again, we've proven that to be true. Now, what happens if we try this out and find it's not true? All right, then we would say there is no solution. All right, and I've actually got one here that's exactly what we're going to do. I have my 3x plus 10 equals 3x minus 4. All right, so I can go ahead and say I can do this a couple of different ways. I could go ahead and just subtract my 3x from both sides. And actually I'm going to do that so that it's real easy to see what's going on. So I have my 3x minus 3x, right? So that means I'm going to have a 10 equals negative 4. And that's a false statement, right? There is no way anywhere in our processing of real numbers on a regular basis that we're going to have 10 equal to a negative 4. It just does not work. So we have no numbers that will work for this. There's no x value, so it's no solution. You can also write it in set notation, which is an open circle with a slash through it. This is not a 0. This is null set. All right, it's very specific. It's not a 0. If you write a 0, that's going to be wrong. Okay, so it's called the empty set, the null set, or no solution. All right, at this point, I'm going to say let's take a pause, and I'm going to see about setting up one more problem, and then we'll go on to the next video. All right, so here's our problem, and I wrote it out in English, and we're going to try translating it from English into mathematics, which is a little challenging because you're translating something from one language into another, because math is a language, and you're also talking about something that's a very unforgiving language. So if you don't get it just right, you wind up with the wrong answer. You wind up with a sentence that doesn't make sense. So let's go ahead and practice this. Let's work through how to say this in mathematics and then actually solve it. So if we subtract 27, okay, we're subtracting 27 from a number. 3 times a number, x, all right, so they're telling us what variable we want. The result is 18. Okay, so let's go ahead and write it out here slowly. Okay, so we're going to subtract 27 from something. All right, so I'm going to say minus 27, and I'm going to have that, leave myself some space here, right? I'm going to leave some space so that I can actually write down what it is I'm subtracting from. I've got my 3 times my number, and we've said that that variable is going to be an x. The result is 18. Well, the result is the same as equal to 18. So we've written it out. It says we subtract 27 from 3 times a number, x, and the result is 18. So I feel comfortable that we've written this out properly. Now we're going to go ahead and begin the process of solving it. So I'm going to add 27 to both sides. And so I've got 3x is going to equal, that's going to give me a 45, right? My 8 and 7 is going to give me a 15, and 1 plus 2 plus 1 is going to get me that 4 for the 45. Now I'm going to go ahead and divide both sides by 3. And x is going to give me 15. So my solution in this case is going to be 15. So you could say x equals 15. You could also say, the solution set is 15 and put it inside the curly brackets like this. A friend of mine refers to them as Hitchcocks because they look similar to his profile. But I'm going to go ahead and stop this at this point, and we'll pick up in our next video.